Alright, so the other special right triangle is called the 30, 60, 90. It still implies what the angle measures are. This one is not not equilateral, isosceles like the last one. Okay, so you still have a 90, but you have a 30 degree and a 60 degree. So none of these sides are going to be the same. They're all different. Alright, so your pattern, this is your starting point. The shortest side, it's the one across from the 30. It's your X. Okay, but this one can't be X because they're clearly different lengths, right? Even if mine's not drawn to scale, if the angles are different, the sides are going to be different. So this one is X square root of 3. And then this one over here is 2X. Okay? Now notice you have 3 different values here. The way I remember that is 3 different values. We're using a 3. And if you look, these all are multiples of 3. We have 3 different side lengths. On the other one, 2 sides were the same, 2 angles were the same, so we used a square root of 2. That's just kind of a helpful way to remember it. So let me tell you why this works. And remember, the math I'm going to show you is me showing you why it works, not that you're going to have to do that on other problems, because now you have a shortcut. Alright, so I want you to think of an equilateral triangle. Remember, that had a lot of properties about it. What's true about an equilateral, even though my picture clearly doesn't look like it? Yeah, all the sides are the same, and what else are the same? The angles. So if all the angles are the same, how much are they in degrees? How much does a triangle add up to? 180, right? And so if you have 3 equal angles, what is each one of them? 60. So I have 60s here, here, and here. All the same. Now if I draw an altitude, in other words a height, this creates a right angle, right? But what did it do to my 60 degrees up here? Yeah, and half of 60 is 30, right? Also, whatever these sides are, they all are the same, but what happens to this piece of it? It's half, right? So say I told you that this piece was our X. And if it's half of, that means this is X also, right? Over here. So when this, the whole thing, what's X plus X? Okay. So now let's go through and see why this one's X square root of 3. Because I've now shown you why these two have this relationship, right? Why this is going to be half of this one. It's because of this. Isn't that a 30, 60, 90? Hello. Alright, so let's think about our Pythagorean theorem. We're going to do a squared plus b squared equals c squared here. I don't know what a is. That's what I'm going to try to find. B I know is our x. And c is our 2x. Okay. So I'm going to leave these two alone for a second because I don't know what they are. Be careful here. If you just write out 2x squared, that's different than squaring 2x. Okay? When you square 2x, you got to square the 2 also. So what's 2 squared? 4. So I really have 4x squared, right? Okay? Are there any like terms here I can combine? Yeah. How do I get this x over here with this one? Yes, I subtract it. So, and how many is that? Like, what is the number if you don't see it? 1. So what is 4x squared minus 1x squared? It's 3x squared. So how do I solve for my a, since I have a squared? Square root it. So when you look at this, can I square root 3? No. Can I square root x squared? What's it become? So that comes out. Now do y'all see why this is x squared root of 3? Like I said, the good news is you never have to do that part again. Because now we've proven why it works, so we can just use it. Like, we all know now that it actually works, that we're not just making up stuff. And so we can use this pattern over here every single time when we see a 30, 60, 90. Okay? So, like I mentioned on the other side, best case scenario is the value they give you fits the pattern. Okay? So, say I have a right triangle. Here's my 30, here's my 60, and here's my 90. And I tell you that this side right here is 20. Okay? What should you always do first? Putting those little labels on there, right? Okay, so if you look across from the 30 is X, so across from the 30 is X, be careful. Why did I not put X on the bottom even though X was on the bottom here? Yeah, because I turned my triangle around. So if I put X on the bottom, it wouldn't be across from the 30, would it? So always pay attention to that because they can flip that triangle around any direction. Across from the 60, that's our X square root of 3. And across from the 90 is our 2X. Okay? So this fits the pattern for best case scenario because that's a whole number. If it's 2 times something, what times 2 gives you 20? So doesn't that mean X is 10? And if X is 10, what's this side going to be? 10 square root of 3. Okay. So do y'all see best case scenario? It fits the pattern. You have whole numbers here, and you have a square root of 3 here. Now, just like on the 45, 45, 90, sometimes they'll give you, the side they give you is backwards. So maybe they give you a whole number here or a square root of 3 here. So it still has the right pattern, but it's backwards. So that's second best case scenario. That you're still either getting a whole number or a square root of 3, it's just in the wrong place. Okay? So say I have, let's see, $20 square root of 3 here. No, I don't want 20. Let's do 24. 24 square root of 3. Okay. What should I still do first? Yeah, label it. That is my 2X, right? What's this one going to be labeled? And this one? X square root of 3. So let's start with the easy one. Remember, this one just gets half to give us that one, right? What do you get when you half 24? 12. So since this one had a square root of 3, this one's going to also, these two have to match as far as their type of term. Not the number itself. But see how they both have a square root of 3 here? Now this one, it's supposed to have a square root of 3 normally, but X already has a square root of 3. Okay? So when I plug in X, I'm going to be plugging in 12 square root of 3. Right? But that's just the X. I still have this other square root of 3. Doesn't that mean I have a pair of square root, a pair of 3's in the square root? So a 3 comes out. What is 12 times 3? Okay, so you've seen the math for it. So if our pattern is backwards, this number that should have a square root is going to have the whole number. If you wanted to work this direction, say you had this first, how could I have went from the 36 to the 12? Divide by 3. And then once I have that, I can double it to get that. So, see, it's a little bit different working backwards. But just like on the 45, 45, 90, where when you had to work backwards, you were either doubling or halving, depending on which way you were going. Here, you're either going to triple the number to go this way or take a third of it to go this way. But only if it didn't fit the pattern, if it was backwards. If it was like this one, you don't do that. Alright? One final example, and this is like we did on the 45, 45, 90, worst case scenario. It doesn't have a whole number or a square root of 3. It has something else. Okay? So we have our 30, 60, 90. And say I tell you this is 2 square root of 2 right here. Where do my labels go? Yeah, the x goes on the bottom. What's this one? Just x? Can they both be x if they're different? Square root of 3. Yeah. And then what's this one? 2x. Alright, so here, go for the easier one first, because remember, these two always kind of go together. If x is 2 square root of 2, then doubling that would give us what? 4. And then the square root stays the same. Okay? But then over here, if I put this in for x, I've got 2 square root of 2. That's just for x, though, and then I have square root of 3. Remember, you can multiply the ones that are inside there together. So what is 2 times 3? 6. So that's what you get. But see how that pattern still kind of fits from right here? See how that 6 here, if I wanted to go this way, I could divide by 3? It's just if it's inside the square root, you'd leave the outside alone. Whereas here, see how I took this and I divided by 3 to get that? So there's still patterns, but it's just sometimes you got to think about them more or do a little bit of math to see them. Whereas if they fit the pattern, it's literally like on this one here, it's like look at it and you can do it without thinking any math. Alright, so I know you may have a headache by now. A bunch of new information. Alright, now I stand by what I said. This is good news. This is a shortcut. It's going to make things easier. But only once you've had time to absorb it. It was a lot of new information. So work on the assignment. Ask questions as you get stuck. This is not due, well, tomorrow's the Saturday, but it's not even due tomorrow as far as next school day, because y'all don't have school Monday. The next time you'll be in here is Tuesday. Tuesday, you can come in with any questions on ones you got stuck on or certain processes that you couldn't remember, and then you still will have Wednesday to work on it. It won't be due till Wednesday night. Okay? Because, I mean, you're going to need to practice this. This can't be a one-day thing. It's too new and too much to absorb. But the math behind it, the process is really easy once you absorb it. So we'll practice more for a couple days. Okay?